For me, it's four things. So it's less garbage, first of all. It's delayed garbage. It's reimagined or repurposed. So if it's got to be garbage, can you think of another life for it? And I think last but not least, it's non-persistent garbage. You definitely don't want it to stick around forever.
Hello. Welcome to the Good Garbage Podcast. My name is Ved Krishna. My primary reason for existence has been to find ways to leave our wonderful planet cleaner. We will be speaking with material innovators, creators, and propagators to learn from them how we can build for scale and towards a regenerative future. Their stories will help us answer the big question, what is good garbage? We need some wide-ranging people in order to bring real change in any space. Sanjay Monie, the global strategy and marketing lead for Kemira, is definitely one such person. Sanjay dabbled in journalism while studying geology, pursued material sciences for higher education, and then went into pulp and paper, after which he dabbled with silica, graphene, various celluloses, printing inks, and various other materials before beginning his work at Kemira. Sanjay and I met at a conference, I think last year, and he then came and spent time with us in India. This episode enables us to understand how barriers are evolving in the compostable space and how Kemira is leading the charge with its open innovation and collaborations approach. I'm sure you will enjoy this episode. Hello, Sanjay. Finally, we get to meet and do this in person. So that's even better, right? Just so that the audience knows, we tried to record this, 2 times and something went wrong.
Glitches, yes.
Yeah. So. And then we finally get to do it in a better way, like do it together and meet in person and hang out and get to chat. So yeah, just introducing Sanjay. Sanjay Monie is a very dear friend now, and he's the Global Strategy and Marketing Development Manager at Kemira. And they call it Kemira Growth Accelerator. So what's the difference between Kemira and Kemira Growth Accelerator?
Yeah, so the Kemira Growth Accelerator was a unit that was set up a couple of years ago to explore new spaces for us and sort of look at new ways of working that's outside our traditional ways of working. But actually, we're in the process of an operating model change right now. So there's some redefinition of the growth accelerator going on right now. It's going to be, we have some new business units. So we're going to have a place most likely in new ventures and services organization. The idea is for us to incubate new technologies and get into new market spaces, adjacent spaces as well as white spaces. So we started out with basically just focusing on a few key areas, packaging being one of them, because obviously we supplied, products, solutions into the paper industry. And as we've steered ourselves towards a sustainable vision, the whole idea was to have a focus on sustainable solutions for the industry. And being a global company and a European company as well, I think the Growth Accelerator was set up for us to maybe engage across the value chain, with our customers. So yeah, and we've got an ambitious goal of $500 million in revenues from renewable technologies by 2030. So yeah, we have our mandate is clear and it's full steam ahead.
That's going to be exciting times. But of course, we're going to talk a lot more about Kemira. It's a company that I have been inspired by, I've appreciated for a long time, and will bring in some of my stories that
Sure.
you know
Yeah.
about. But let's start with you, Sanjay, the person, and growing up and your background in geology and, growing up in India and how that has shaped you as a person.
So I think we share that in common, obviously, growing up in India. I grew up in the city of Mumbai, then Bombay. Grew up in a fairly westernized, I would say, upbringing, spoke English. My entire education was in English, was exposed to Western culture growing up.
Does that mean like lots of good music?
The bands from the US, and, every time somebody went abroad, you had a list of cassettes and CDs you wanted them to bring back with them. So I grew up with those influences. I went to St. Xavier's College in Bombay, which shaped, I would say, my personality more than my depth as a technical person. But it was a great all-around institution as well. I really honed my skills coming back to the US. But yeah, I studied geology there. There in India, obviously, if you do well in certain exams, your path is kind of set for you. So I got a good enough marks in my 10th grade that I ended up going towards the sciences. and I did my undergrad in geology. So that was a key part, was an early introduction to the earth sciences. You didn't take it quite so seriously there, but I always had an interest in writing because I come from a family of writers. And my mother was a journalist, my cousins are published authors, and so forth. So I was dabbling in writing for a newspaper back then called the Indian Post, and I was writing features for them. And back then, a story about global warming and the greenhouse effect. So I would say I wrote an early article sort of sounding the alarm a little bit on climate change and global warming, as was the phrase back then. So that got me interested in this whole issue of responsible towards the environment. And of course, in India, you do see all the discrepancies, the divide between the privileged and not so privileged. So obviously, the garbage problem is huge now. It wasn't quite so much then, but you still got to see a different side of life. Yeah, so I think all of those shaped me. I think the other thing that shaped me was this idea of repurposing. I mean, everything in India gets repurposed when we were kids. Yep. Nothing didn't have a second or a third life. You never just threw things away. You had knife sharpeners coming by the house, yep, and sharpening your knives. You had people who came, shoemakers, everything, you just got it repaired, brought it to its logical end of life.
Yeah. My mother used to keep all these poly bags somebody would get under the bed. So we knew if we needed a bag, where to find it.
Exactly. I think all those influences sort of cumulatively have sort of shaped your sense of the world.
Even as sciences, geology is a specific choice, because I know that a lot of people would go into physics, chemistry, maths, or physics, chemistry, biology, yeah, but not that many people chose geology. How was that choice made for you?
Primarily, it was the professors there. I got to know some of them. We took classes in geology. I got along very well with a couple of professors there. And yeah, it just seemed like a fascinating subject because minerals are fascinating to me. I still have a collection of minerals at home. People come and they quiz me on every time they're home.
Selection of minerals.
Yeah. Let us play case, and
I have to come see that.
Sanjay. Yes, indeed, you should, absolutely. So that it's one of those things that, and it's really the foundation of material science because geology is really a natural. It's the natural materials that human beings have figured out the fundamentals of, mm-hmm, and then they've turned them into usable materials. So understanding, it was an early introduction to the fascination of how natural materials can have such perfect surfaces and crystal structures and so forth. Yeah, so I think it was just a very fascinating field to get into. And then, you learn about stratigraphy and the age of the earth. And yeah, you don't really know what you're getting into, and it becomes endlessly fascinating once you get into it.
Yeah, and especially considering that you were being raised in Mumbai, which was mostly one mineral, concrete. So that's cool that you actually expanded the horizon of different minerals.
Exactly. And then going on, field trips, it was always fun, a very nice bonding experience. So I got to do things that your traditional physics, chemistry majors would not have had to do, right? In all of those classes.
So I had this huge list of your interests, and I'm going to add to that interest minerals collector. But I want you to talk about sketching, cooking, photography, language, trivia. So this wide array of interests, and I think that also shapes your personality so much. There's this curiosity. What I find in you in the little time we've known each other as that you are endlessly curious. That I know you, when you even visited us in India, you wanted to go see things. So It was immediate. Look, can I go see this? Can I go see that? So just talk to me about this wide array of interests and how that feeds your soul.
Exactly. I have sort of a left brain, right brain personality. So my more analytical side is something I've developed through, work and school and discipline of that sort. But every once in a while, I need an escape towards the other side of my brain, which is the more creative side. And that finds expression in, I don't consistently do all these things that you mentioned, but I certainly dip into them every once in a while. So, but cooking, I would say, is something I enjoy, but it's the creative side of it. I like experimenting with tastes. And like you said, I think I like figuring things out. So if it's something, whether it's books, reading, I'm always trying to find that nugget of an idea there, that's unique, a new insight that I didn't have before. Or in cooking, I'm trying to see what flavors might be compatible with each other and why. And if they're not, why not? So sketching is something, again, it's one of those things that my father actually was a wannabe architect. So I think I get some of that from him. But I used to do portraits of all my housemates in graduate school. So so those are things I don't do that as much anymore. Writing language, I can pick up languages somewhat easily, I would say. So I speak, three or four Indian languages. I could stutter along in French, Spanish, depending if I'm in the mood. I can also sort of get by. But yeah, so language fascinates me. So these are the part that give me, the relief from the using the analytical side of my brain.
And I've seen that in my life. Of course, I don't have engineering background, but I've been blessed, I would say, to hang out with lots of good engineers. And I've seen that consistent pattern that all good engineers have an art side to them. It's so interesting that, I know one of the people who taught me a lot about boilers, amazing artist and amazing musician. And similarly, another person who taught me a lot about projects, and he is heavily into astrology, and then goes deep into it, but also has this kind of fun side to that angle.
Right.
So so just this variety. I think it's the balance, like you were saying, the left and the right brain, and in order to be a holistic person, I guess you need to use both.
Yeah, I think so. And the other thing I think you get satisfaction from is seeing the end result of your labors, right? So there is a certain gratification to, you know, how it turned out after you experiment with the food, for example, or photography. I mean, I don't use fancy cameras, but I think I have an eye for capturing a good shot. So, there's that gives me satisfaction to then try and sort of tweak the picture so it looks like what my mind's eye saw. For example, a conversation I had with a friend who said, do you think you should manipulate pictures after they're done, or leave it natural looking, which is the way it actually was? And to me, my belief is that your mind's eye saw that a certain way, which may not have been just
The real what it was.
So to me, I'm trying to capture that, the specialness of that picture, right? So yeah, to me, reality for me was what I did with that picture afterwards, not this just bare picture that was captured. So yeah, I think it's those kinds of things that I enjoy. But also, even at work, I find, I like problem solving. For example, if you give me a problem, I'm like, okay, how do we resolve this? What's the solution here? So I think that satisfaction of seeing things, to a point where you can look back and say, now I like it.
I think it's the detail orientation, probably in an engineer's brain, a good engineer's brain, that even when you're doing your cooking, you want to go into detail. A photography, you again want to get a little more nuanced. That's what I think makes it click and be special. So I'm going to switch gears so that we keep moving and take you towards barriers and packaging eventually.
Yeah.
So you moved to US. Why? And then of course the especially the education side. How did that evolve? And I know you went into different, again, similar but different kind of domains. So let's talk a little more about that.
Yeah. So when it came time to graduate there, it was a choice of, do I want to do graduate school, or I had an opportunity to become a copywriter. So, like I said, my life could have gone in either direction at an advertising agency, because I had a lot of friends who were in the advertising world. But it was also one of these things that I had, like I mentioned, the professors in geology there, they had, they recommended that I explore graduate school in the US. So I took the GRE and the TOEFL, these exams that you have to take. Did pretty well, applied to a bunch of schools and got accepted. I didn't know one school from another. Then, Penn State, which is where I ended up, was a school that my professor looked at the roster of professors there and said, these are heavy hitters in this space. So that's where you need to go. And as it so happened, I also got a scholarship there. So my education got paid for, which was a huge relief to my dad, I'm sure, at the time. So that brought me to the US to do a master's in geology. And then somewhere along the way, I was studying the weathering of calcite, which is this carbonates, basically. So you're studying the surface chemistry of that. And I was working on this instrument called an FTIR, infrared spectrometer. And there was a professor from the material science department who was studying the corrosion of glass. So he asked me if I could do some experiments for him. And then basically talking to him, I realized that there was a whole new world of materials that was really interesting to me, and the job prospects were a lot better. And material science at this time was just about emerging as a discipline. It was a brand new field in the US because it was interdisciplinary. You took from all the other traditions and you fused them to form this new field. And Penn State was one of the pioneering schools in material science. The Materials Research Society was founded at Penn State. And so that was a chance so I was one of the first graduating batches, I think, from Penn State to get my PhD in material science.
it's so interesting because I think coming from the pulp and paper industry, I find typically we hire people who've been in the cellulosic domain. So it's kind of kudos to Westvaco and all the others, you kind of WR Grace and people you went through to actually think more broadly, because I also find that to be a huge challenge when we become a singular discipline that we only know cellulose, and that's something that that I struggle with.
Right.
Because get people out of that mindset that there is materials beyond cellulose, and you can also cross functionality of material happens.
Absolutely.
So yeah, would love to hear more about why pulp and paper and why this company decided to hire material scientists instead of pulp and paper technologists.
Yeah, and I think so. Westvaco at the time, this is just before the merger with Mead, was sort of like the training ground for the paper industry. It was one of the companies that hired a lot of fresh out of school graduates and got them started in the paper industry. A lot of them have gone on to become quite prominent in the industry, but we were a whole cohort of people that were freshly minted PhDs there. And I think they wanted to basically, it was the Alfred H. Nissan Technical Center in Columbia, Maryland. And we had just fresh out of school PhDs from different disciplines trying to bring new ideas to the table, really. So that was the earliest days of inkjet printing when people were starting to use their home printers to print out photographs. So I got a chance to work on developing glossy inkjet paper that could be home printable, that looked and felt like a real regular photograph. I had no idea that there could be so much fascinating stuff about paper. Obviously, as with any material, it sort of takes things for granted. And they thought, oh, what could they possibly be hiring so many PhDs for in a paper company? But you get in there and
it is the most fascinating material, right?
It is, exactly.
From my point of view.
Yeah, but it was not even what I would have considered material before that, because paper was paper. I was working on ceramics and things like that. So I ended up working on inkjet, and that was endlessly fascinating because the challenges of trying to get gloss while the mechanism of printing, for example, inkjet, water-based inks, is that you have to somehow separate the colorant from the vehicle, which is the water. So the colorant, which could be a dye or a pigment, has to stay at the surface, and you have to very quickly get the vehicle, the water, away from it. Otherwise, it starts to stick on the surface, stays on the surface, and coalesces and bleeds and things like that. So you've got a dye fixation that has to take place right at the top, and very quickly you need porosity or something to suck up that water that's in the ink. And ink would be like 96+% water. So it was a challenge because getting that, and the way the paper industry typically gets gloss, for example, for glossy paper, is calendaring, which is
and coating. And closing the surface.
Exactly, you're closing the surface. So that was a challenge to find a way to get gloss without sealing the surface. That was also cost effective because, when inkjet first started, it was $2 a sheet for an inkjet paper. And, and traditional printing, prints were dirt cheap. So great technical challenge, and learned a lot about, binders, pigments, formulation. I have a patent actually in a glossy inkjet paper that I ended up getting. And that was using fumed silica and fumed alumina, which turned out to be wonder materials in terms of the ability to get sort of gloss with very minimal calendaring, just enough to give it a sheen, but without having to seal the surface. So the morphology of the surface takes on this sort of wet look that gives it glossy appearance. So that's what I ended up spending my time in the paper industry.
Just before you move ahead, because I'm just curious about this now. So we would, of course, use a 35 mm film, and we would give it for printing to a photography shop.
Right.
So, and their system presumably was different than an inkjet printer.
Sure.
So was there a difference between the properties of the paper that they were using because of the process? Because how were they printing? Because they would have the same challenge, right? Ultimately, it's ink of some kind,
right,
that is going on the surface. And then inkjet is different.
Yeah, so that's a chemical process. You've got developer, it's
the black room.
Exactly. So you expose it. It's a very completely different process, right?
And there the absorbency,
all those things. It's all a chemical. It's
true. It's just putting the chemical on it, and it's appearing.
Exactly. That's the key phrase. It's on it. Yeah, your image appears.
Yeah, I forgot the dark
room. All right.
It's been that long.
Yeah, but then again, of course, cellulose acetate film was film material, which is why it used to be Eastman Kodak, and Eastman made the chemicals, the acetates that was part of that made the film. And then they split, of course, because Kodak then as did. And this whole new field emerged of, the printing companies like HP and Epson becoming the sort of associated with photography more so than the old Canons and the Minolta and those companies, which never got into the digital printing side.
Yeah.
So yeah, it was really fascinating to see these new names suddenly being associated with imaging rather than the old photography.
Yeah. Including the camera companies.
Exactly. Yeah. They exited the field almost. Some of them did. Some of them were a little late to the game, like Kodak, which, changed its fortunes.
Yeah. And then you go on to other paper companies like W.R. Grace.
Grace was a supplier to me, actually.
Okay.
Because I was looking at some of their silicas when I was and then when I'd moved over to Grace, my boss there was somebody who kind of I'd interacted with as a supplier. And he offered me an opportunity to move over to Grace when the merger with Mead happened. And I moved over to W.R. Grace. And so there I continued working with now their materials, which are all these silicas. So they had colloidal silicas. So we were developing basically formulated coatings for inkjet again. This time I didn't have to restrict myself to Westvaco's substrates. I could use any of the paper industry substrates. I got quite involved with TAPI. I was actually the chair of the local Philadelphia, the Delaware Valley TAPI chapter. I got involved. I was on a standards committee for image permanence, an ASTM standards committee. So yeah,
Network didn't realize you were not a cellulose scientist.
No, I think it was more organizational. I mean, that gave me, the sort of exposure to industry networking, things like that, and building an industry network, which is critical, I think, to succeed, is having a strong network in industry. So I think that early start allowed me to sort of have people I could call upon if I had an opportunity or a need, building that Rolodex of contacts.
On that. And for the listeners, I guess we throw around these words so easily. So TAPI is the Technical Association for Pulp and Paper International, which kind of leads all the standards and direction for the pulp and paper industry. Yeah. And then, of course, interestingly, you get into the other side, which is inks, graphene, and Vorbeck is again, Vorbeck materials is something you get into. And that's a very interesting phase as well.
Yes.
So how did that shape your thinking?
Yeah, so graphene was this new wonder material that had just won the Nobel Prize. And an ex-colleague of mine at Grace was one of the co-founders of a company, again, very located close to there, called Vorbeck Materials. And they were one of the first companies to get, an EPA permission to manufacture on a small scale. So graphene, sort of industrial scale graphene manufacturing. So graphene is a single sheet of carbon, basically. So when you look at, think about carbon nanotubes, they're sort of like a cigar-shaped version of a graphene sheet that's rolled up. Okay. And CNTs, carbon nanotubes, had been around for a while and had shown some of the promise, but when somebody, actually the way the Nobel Prize scientists from UK isolated graphene was literally a Scotch tape that they peeled layer by layer. So a stack of graphite has millions of sheets of graphene, and they literally used Scotch tape to isolate a single sheet of graphene and measure its properties and found that it was the most electrically conductive material ever known, the strongest material ever known. So there was huge interest in graphene. It exploded in interest. We were a pioneering company in that space. So it was a great chance. And that's where I got a chance to actually transition from the technical side to the commercial side, because I'd realized actually in my two previous jobs that I really enjoyed market understanding of it. Like I said, I like seeing the big picture. So for me, much as I like the technical side, I really wanted to understand how these become products that have a place in the market, not just something that you develop and then see if there's a home for it. So I was a director of development at Vorbeck and got to, get a seat at the table with some high power companies. We did JDAs with BASF, with Quartz, these are global companies, getting a seat at the table, trying to pitch investments to large companies, a very large petrochemical company in India that everyone's heard of.
Big wedding, you mean?
Yes, exactly. So they, doing the due diligence with them, trying to answer their questions on investment, building the business case. So it was 4 years of boot camp, I would say, in business. So that was really eye-opening for me. We actually launched the first commercial application of graphene in conductive ink in a package, in an anti-theft package. That was, again, full circle back with Midwest Vehicle. It was called Sirens. So you basically had a problem with retail theft where people would basically steal. They would go to a store and items that cost $20, $30, they would cut the pack, put the item into a bag of soil or something like that and walk out with it. And that was causing a huge loss to the retailers. And so we worked to have a conductive ink with a alarm that was mounted in every individual package. So if anyone cut that, it broke the circuit and set the alarm off.
Oh, wow.
And it would also set off the towers in the stores.
So where would it send the signal? Say if I'm going into a store and cutting something,
right,
there has to be a transmission of.
No, there's an actual transponder on top of the package. Every package had that. So it was good for the for the brands, because then a lot of that stuff was behind lock and key because of theft.
Yeah.
But this allowed,
they could now put it
now
out.
They could put it out. Customers could interact with it, see the branding that's on the package. And then if they tried to steal it and run away from the store, it would not only set off the alarm, but it would set off the towers as well. And we actually launched this at the Consumer Electronics Show in a booth with Midwest Vehicle. Of course, Midwest Vehicle has been through so many transitions. This became a project that they discontinued after a while. But so that was really exciting. We won an industry award for that. So we were sort of pioneers in that space. Actually, if you look at the applications for graphene Wikipedia page, my name is in the list of references for graphene. So yeah, that was my transition into the commercial side of things, which is what I've done ever since. So I've been on the business side.
And that's something, again, that is such a huge challenge. And I guess you kind of managed to get over that hump, because I find, with lots of very, very good R&D people, if you don't connect with the market, then it's again in isolation and it doesn't see the light of the day. And, we are doing various things within, and intellectually stimulating, but ultimately non-application oriented. So it's great that you actually went towards, understanding what the customer and the market.
Exactly. And the importance of, for example, economics, in these things, pricing, for example, the fume products that I was working with to develop this glossy coating, while they had those wonderful properties of being able to be, calendared very likely to get the gloss, they were manufactured for polishing of silicon wafers. So they didn't have the scale to supply this market for inkjet. And so it was $20 a kg for that. And we didn't get that realization till I was well into development. And then we started to have commercial conversations. And I remember everyone's face in the room went pale when they told us what the price was going to be, because the paper industry is, expecting an expensive pigment there would be like maybe $2 or something like that a kg. And this was $20 a kg. So this was a reality check saying, ask the right questions early on some of these things, because all of these things are important. Commercial viability depends on more than just technical success. It has to, even if you're not getting, you have to map out what the vision is for the pricing. So how does it get acceptable in the marketplace?
And we struggle with it every day. And it's about value creation.
Exactly.
I don't think lots of people will just steal at price. Exactly. But price is not the point. It is the value creation. Absolutely. That you actually, are you being able to drive value for the customers in one way or the other? And then it's about communication. That yes, you're being able to drive that value, and then the customer can.
Yeah.
And I'm saying this specifically because a lot of the listeners will be from the sustainable packaging space.
Right.
And that's something we all struggle with, because, I think even the starting point, interestingly for me, and of course, it's much easier for me to say it coming more from the management orientation than the actual doing orientation, is that, the starting point itself is that our product is going to perform poorer and be more expensive than a petroleum substrate.
Right.
And that in itself, I find faulty thinking that, if you start there, then you can't make...
You don't have a message to sell then, right? I think the value in use is important. And I think the idea is to try to, there's many different ways. So it's really about, again, do a techno-economic model, figure out the value in use, figure out how the package can be redesigned, how it can be light-weighted, where's the savings coming from. It's not all just the materials cost. So you want to paint the fuller picture that has to do with the use cost, really. And eventually, is there a pathway to getting to be either a new normal or the price down to where it's viable? Again, it depends on scale, of course. In some cases, it might be that you reduce the kind of packaging. There's so much innovation happening in this space that I think to be singularly focused on materials cost is a bit short-sighted. I mean, it's important. Obviously, you have to get the materials cost down as much as you can, but then there's other ways to create value. You can enhance the performance, and people pay for performance. So it's being cost competitive rather than at parity. You want to try to make sure you're fair. Your pricing matches the expectations of the market within a reasonable range, and that's the target, right?
Yeah.
So
I would even redefine it as value creation. So you can be much more expensive,
correct,
but then the customer has to get deeper value,
absolutely,
one way or the other, whether it's through brand propositioning or whatever it is,
right,
or performance, or design or something. But you have to think from that standpoint. So just quickly wrapping up your journey till we reach Kemira, and then you get into carbon and you get into cellulose acetate. So tell us more about those materials, and again how you see them having impacted your thinking.
Yeah. So carbon, obviously graphene was my introduction to the world of carbon. Then I joined Orion Engineered Carbons, which is a carbon black company. Again, one of those materials. It's like silica is called white carbon. It's like white carbon. They're similar in terms, a lot of similarities in properties being carbon black and some of the fumed silica. And again, you get into it, so I was on the specialty carbon black side for Orion Engineered Carbon, which used to be the carbon black business for Evonik, which had spun off on its own. And we really grew the specialty side of the carbon black business, and I was responsible for the business for the Americas in printing batteries and special applications. So, I had a technical team that went and did the technical marketing of this, but it was, covering all of North and South America, but getting into the digital printing spaces as well as the traditional printing. You realized, back then you started to get into the FDA requirements for print, for the printing ink. So you get exposed to that side of packaging. You realize the printing is an essential part of packaging, and carbon black is the black pigment that you see. So yeah, we became the market leaders in the Americas in the printing industry. So that was sort of a good accomplishment there. We sort of became the key carbon black supplier, I'd say, to the printing business here in the Americas. But I was there and then working on batteries, which is also a new space, so more conductive carbons. Carbon black is actually a very fascinating material as well because it's got color, it's got UV resistance, it's got conductivity. It's used in plastics for UV resistance. It's used in paper as a pigment. It's used in these jet black coatings you see in cars and things like that.
Tires as well.
Tires is like the big volume driver, but the profit drivers are the specialties. So I did that, and then I moved over. Sustainability, like I said, was growing as a space. And an ex-colleague of mine from West Waco actually was at Eastman, and he was setting up a team looking into bio-based materials for sustainable packaging, and had told me about this opportunity, and I joined his team and worked at Eastman on the event compostable materials platform, which is part of the innovation platform. And me and the team led the first commercial. We had a stage gate process. We took the first product through the commercialization stage into the market.
Yeah, this had evolved from their background in cellulose acetate films, like the 35 kind of camera films, and they had kind of, obviously that was a market that was dead.
Right.
So did they evolve that product to get into this domain, packaging, or was it a totally different structure?
The realization that it's a biodegradable material and has a really good favorable end of life is what the message for that. And it's part of their, again, Eastman is very sustainability focused. So that was a pivot they were making. So this was a way for them to incubate new products into the market. And this was an emerging platform that came out of some technologies and expertise that they already had in the house. So brought in some new folks with some new thinking to explore this market. And this, again, I think around 2014, 15, you started to see sustainability emerge as a trend in industry. Everyone was having, whether it was carbon black or whatever, everyone was trying to figure out how to make their products more sustainable. This was a natural evolution for packaging because it had the properties that would allow it to substitute in for some fossil plastics.
The Good Garbage podcast has been brought to you by Packer. Paka has been creating solutions in the food packaging, carry, and service space. Paka utilizes sugarcane residue and upcycles it into amazing products. Their latest offering is a compostable, flexible packaging solution for the chocolate and confectionery industry. The products are available in the Indian subcontinent and in North America now. Paka is also building an end-to-end solutions for customers in the food service and delivery space. For any query, do email at connect@paka.com, and Paka is Pakka. Now, back to the show.
And of course, now we get to the crux of the conversation, which is this fascinating company, Kemira.
Yeah.
And I've, of course, like we've discussed before, I've known Kemira for a while. My personal experience has been very positive with the desire to do interesting things. And like, I know, you know, the story where, you know, there was a Kemira came to us that they wanted to have a sizing program at the mill, which was ASA. And we felt that we didn't even think that it would work in our structure. But the fascinating thing was that the effort, you know, and yeah, in the end, it's not about success or failure, but just this desire to do it right, to set up a plant in a small mill and to actually do a program and to try really hard and to post people there and to just try and do your best.
Yeah.
Which has been fascinating. So it's first starting with, you know, why did you want to shift to Kemira? And then, of course, we'll get into more detail of what is Kemira and what do they do?
Yeah, so they had this opportunity again as part of the Growth Accelerator to get into the space. And so, yeah, I came across it. I heard about it through FPI, actually.
FPI is in
Food Service Packaging Institute. Yeah, so that's how I first learned about this opportunity. And then, you know, just learning more about the product line, because they're a Finnish company that's got a very storied history, 100-year-old company. And again, very sustainably focused. And this Growth Accelerator was a very exciting opportunity to really shape the future of this company in this space. So I think the idea of broadening expertise in this space, bringing the value from all the materials learnings, all the other insights into this space was an exciting prospect. And like, you know, it's a technically sound, very, you know, crack technical team, very, very clear on its vision to be a sustainable solutions company. So those are, you know, a core part of our identity and this commitment to our customers. So I think when you go to a customer, yeah, I'm glad you say you got treated the way you did, because, you know, this is the kind of follow-up and commitment we show to our customers. So yeah, we become journey partners in a way, you know, and look for solutions together. So yeah, I think that's how I ended up here. And now we're getting into, so my role is fascinating because I get to plug into the industry and bring my insights to the table, but also bring back the trends to the organization.
Yeah. But let's dig a little deeper into Kemira. What's the background? How did it grow? I know that, you know, they've been in water chemicals, sizing chemicals. And then, of course, how are they seeing this transition into sustainability? Of course, they've been sustainability oriented,
right?
But now it's a very specific desire to get more and more aligned to panniers and other kind of products.
Right.
So yeah, a little bit more insight into what Kemira does.
Yeah. So, you know, we were heavily focused on the water intensive industries. Water treatment is a key market for us. Again, these are all crying needs on the planet right now. Water is a critical resource that is in jeopardy. So water treatment, especially in the developing world, is a critical issue. So this vision of a sustainable future is sort of a driver for us to really also get outside of some of the comfort zone of like being a supplier to a solutions provider. So we're trying to engage more with the ecosystem, like I said, which is, you know, in these industries is not the traditional business model. It's typically you call on a mill or it's a key management type approach. So this is a way for us to really talk to our customers, talk to the converters, create the pull for the products. And everyone now, to be honest with you, even the brands have their own experts who ask very detailed technical questions. So you really have some really meaningful conversations all up and down the ecosystem. So I think it's the way the industry is working itself has changed. One of the comments that stayed with me from like the Pack Expo 2 years ago at one of the panel discussions here was they said, if you'd been here 10 years ago, these conversations would be happening at a coffee table somewhere. And now sustainability is the whole show is pretty much about sustainable solutions, right? So while there's a lot of energy, but there's a lot of dynamism, but obviously things have to settle down. So there's a lot of competing things going on right now that need to coalesce. And I think that will happen. But I think it's really energizing to see all the enthusiasm around this space and all the creative ideas that are emerging for this. And, Kemira plans to be a key part of this. We plan, our vision is to be the leader in this space. So,
yeah, I'm sure you will be. And just for the listeners, again, we are meeting at the sidelines of the Pack Expo in Chicago. So just the reference to Pack Expo. So if you look at the entire portfolio of Kemira, so this is a huge move that it's making. So what does the portfolio look like now in terms of, distribution? And then what is Kemira looking at? How is Kemira looking at it shifting in the next few years?
Yeah, so we see a big opportunity. Barriers is a focus for us, renewable technologies and barriers, because there are some critical needs there. PFAS, there's materials that are being phased out of the market. Our vision is that there's going to be there's a secular trend towards paperization. We're seeing that the plastic crisis is huge. When you look at some of the numbers, in the next 20 years, you're going to double the amount of plastic that's disposed. You're going to have, 3 times the amount of leakage into the oceans. You can have 4 times the amount of plastic in the ocean. So these are crazy numbers that you can't really, something has to be done. And we see a trend towards paperization, especially. It's not going to be universal, but there are some applications where paper makes a lot of sense. And we're focused on that. And PFAS provided a lot of the barrier properties, and that, forever chemicals are being phased out, as everyone knows. With polystyrene, EPS bans, for example, that's another space that we see potential for new solutions to emerge. So for us, the fact that we believe in partnerships, we formed some critical partnerships in the industry, and we're working on some barrier technologies based on our PHAs, and as well as with these designed enzymatic biomaterials in a partnership with IFF. So these are partnerships we have with Danimer and with IFF to develop barrier technologies. So this is a big focus for us in the packaging space. But then we're also looking at, other spaces like textiles and nonwovens and where these products can be used. OGI and molded fiber, for example, is a big need right now because of PFAS. So that's an area of specific focus for us. So, and then we believe that aqueous dispersions are the way to go. So applying water-based dispersions on coaters, where we're focusing our efforts right now to develop those barrier coatings.
You've said about, you don't realize this, but you've said about 5 things in this which needs to be parsed out. Because obviously as a person who's deeply immersed in this, you understand this area so much. But I'm going to go back to the original question. And this is coming from a place of curiosity on how companies are moving. So if you are to parse out the whole pie in Kemira's world, I presume today it'll be a lot of water chemicals. It'll be the chemicals that are used for sizing and things like that. So if you look at that whole pie, what does that distribution look like? And then is there a certain plan for Kemira that we are going to keep moving more? And like you said right now, it's going to be a lot more barriers and things like that. So how does that, and then you don't have to be specific, but in a broad outlook, what is the percentage shift that will take place?
Right. So, with this operational change that we've announced right now, we're getting more focused in the markets that we serve. So we have the packaging and hygiene solutions is going to be a standalone business unit. And these are for essentially the commercial ready products that we have a portfolio for to provide these solutions in the market and do that in a very focused fashion. Then we have the global water business as well, which has been our stronghold for many years. Then we have fiber essentials, and they were going to, so that will be some of our core chemistries for the fiber processing. And then we have the new ventures and services, which will have digital services as a key part of it, as well as some of these new exploratory areas. So we're really focusing as well on digital services to enhance our customer.
What does that mean? Digital, is that just to do with the service and the data kind of?
Yeah, so it's people's to monitoring tools and data optimization, so that we can provide value creation, resource efficiency solutions to our customers. So that's how this company is currently seeing itself.
It's a big shift.
It's a big shift, right. And it's very market focused, and so we're really excited that we're taking this move now to the next level.
Yeah. So you've mentioned this word aqueous coating and water-based coating. Again, just for the knowledge of my knowledge and for the listeners, how does it differ? And of course, when I look at nature, all chemistry is in water. That's the solvent. But of course, I presume
what you're saying is that a lot of the chemistry that we do in the industry will be different. And why is it important to move into water-based chemistry?
Yeah, I think there's some flexibility you get from water-based chemistry. I mean, first of all, there are many different ways to coat with water-based dispersions. So you can have, blade, rod, gravure, flexo, slot dye. So there's a multitude of ways you can apply water-based coatings on coaters. So there's available expertise in the industry for that. You don't have the VOCs issue that you have with solvents.
VOC mean
volatile organic compounds.
Yeah.
So the solvent-based is essentially more or less disappeared from some of these markets. Coatings and inks used to be a lot of solvent-based inks, and there's been a shift away from that towards aqueous. So it's a environmentally friendly health. You don't have the same health hazards you have with some of the solvent-based technologies. So we're developing that approach to applying these coatings with our customers. So essentially, that's where we see the potential for these products. Now we're in the midst of several successful trials applying these on machine, not on off machine, on coaters. So that's sort of where we see the future for coatings. Of course, then there's applications like molded fiber where we're looking at methods like spray coating or dip coating as other ways to get these products the barriers onto the material.
From a user aspect, as soon as we hear aqueous coating, do you think that it is automatically environmentally friendly, or it is more detailed, nuanced than that? Because I guess water-based chemistry also, you might have things which, I don't know, will that be, is it an automatic thing if somebody says it's aqueous, or there is more nuance to it?
I mean, there's other additives, of course, but you always do your due diligence. You want to make sure that all the additives are safe. And that's why we rely heavily on these industry certifications. So,
no, I'm not talking from a chemical standpoint.
Okay.
I'm talking more from a generic standpoint. So if there's a buyer who's looking at coating solution, the supplier says, oh, this is really good and it's environmentally friendly because it's aqueous. Is it that simple, or is it more nuanced than that?
Yeah, generally speaking, I would say yes, it is. Water-based dispersions are generally considered environmentally friendly, but you have to understand the full composition of these. But you don't tend to use a lot of harmful chemistries in these coatings.
Good. No, that's good to know, because that makes our life simpler as users. So, and the other one which we were talking about yesterday, and you've mentioned it a couple of times now, dispersion versus extrusion. And how does that differ, and what is the property impact when you do dispersions versus extrusion? And does it also ecologically, is it kind of different as well?
Yeah, so they're different. I mean, and when you're looking at some of these, extrusion is essentially you melt a film and apply it on the surface. So there are some products that can only be applied by film extrusion, but some of these products that can be dispersed in a medium can be applied by either. And extrusion has a lot of installed assets. That's how the traditional HDP, LDP films have been applied onto substrates. But some of these new barrier biomaterials, especially bio-based, it's not quite so simple. They don't have the same film forming properties as traditional plastics did. So they often have to either blend or add plasticizers to get it to extrude properly. They both have their place. I mean, extrusion, there's a lot of installed assets, but it's a little trickier, from my understanding, to apply the extrusion coating. So it takes a little more experimentation to get it right. You tend to get thicker films with extrusion. And so if you're trying to really get thin, your dispersion has better prospects for doing that. It's harder to recycle sometimes extrusion because the broke system, for example, cannot be easily handled, or separating the extruded film from the substrate can pose challenges for recycling systems. So those are some of the issues that the extrusion side has to deal with. Adhesion, for example, it may need a corona treatment or some sort of an adhesion promoter to get the film to stick to the surface, depending on the kind of substrate you're applying it to. On the dispersion side, you can get thinner coatings, so that's huge. It's got better end of life in terms of recyclability because of that, partly because you can make the coatings thin enough. But it does have, a learning curve as well. We have to deal with drying. There's a lot of water we have to get rid of. Shipping and transportation, if you're shipping a lot of water, can be a challenge, obviously. So you got to figure out where do you do the actual make down of the dispersion coating. How do you disperse it? It takes, certain kinds of equipment to disperse it properly. And those are all the learning curves that go with making successful dispersion coating. On the extrusion side, the other thing is a lot of these biomaterials, like I said, either need plasticizers or they're looking at blends as well. You can't really get a pure material. So now when you blend it, are you getting the same end of life performance as you did with a pure material is a question. So I think there's efforts on both sides. And for some materials and some products, I think extrusion makes the logical sense. And some other applications, dispersions are the way to go.
And how do you look at, say, internal chemistry, internal sizing in stock versus an external coating, kind of spraying, as you said, mechanism? Is there a lot that can be done? Say, let's look at molded fiber. So, and that's an area that is growing so much. And of course, it's much easier if you can solve the challenge internally, right? Like put it in the stock, put a chemical in the stock. But again, it has its challenges. There's a lot of water that is floating around. And then, of course, you have the spraying system or the lamination system. So how are you looking at that aspect? Are you guys looking at both, or are you focused on a certain?
Yeah, so molded fiber, we're looking at both because, obviously the traditional, when you look at molded fiber because of the nature of the surface and the porosity, getting a hermetic layer as a barrier with a dispersion application. First of all, because of the 3D shapes, you can't use the same process to apply the coating. So hence spray coating or dip coating as ways to get that site, the barrier onto the material. So we're looking at both applications that involve targeted barriers just on the surface, because when you're doing an internal barrier, there's a lot of product that is not essentially needed to provide that barrier. You're just doing a brute force application of the barrier. Yeah. So spray allows you to be more targeted about it. So I think those are some of the considerations in terms of material use. And so we're developing, for the molded fiber side, we've got a lot of other chemistries, but on the barrier side, we're looking into new OGI chemistries because we see that the PFAS need elimination is very critical in the molded fiber space. So that's a real imperative. So to have a solution that works for customers with the OGR properties is a push for us. On the coating side, on the FMCG packaging, for example, flexible packaging, or even rigid cups, those are the programs that we have going right now. So we're looking at more applying the PHA. And now we have a program where we're developing high barrier applications using the DEB platform, which is the designed enzymatic biomaterial IFF-based technology for basically shelf-stable oxygen barriers.
Great. So yes, I've been fascinated with this whole PHA domain, and clearly Kemira must have done its groundwork before choosing that's going to be a substrate that you're going to work on. Yeah. So how did that come about? What does, and for the audience again, what does PHA mean, and why did it take Kemira's fancy, and how are you guys looking at evolving that?
So I think PHA is, well, first of all, it's unique in that it's a family of material. It's a family of compounds. And so you have a lot of flexibility in terms of properties. And it's unique also in that it's the only one of the bio-based materials that can have a responsible compostable end of life that promises the home compostability as an end of life material. So those were compelling properties for us in terms of selecting PHA. Also, the fact that it doesn't have some of the brittleness and things that some of the other materials have, that it can be applied in as a flexible film. There's ways to play with the crystallization and the chemistry of it as well. It gives it different properties. And it doesn't compete with resources for feedstock. So, for example, we're partnered with Danimer that uses canola oil as a feedstock for their PHA. It's a PHP actually, but it's a family of products. And so, yeah, I think for us, that's why we selected PHA, because we wanted to have multiple options for end of life for our customers. So beginning of life and end of life are both important for us. So the beginning of life, obviously, that it's renewable bio-based is very attractive and compelling. It's starting to mature to the point where it can be manufactured at scale. Danimer, we believe, has proven that it can manufacture at scale. That's always obviously a concern for industry. So having a product that can be supplied at scale to the market, that we can bring a unique way to apply, which is dispersion applied coatings, and that provides multiple end-of-life options to our customers, was pretty important for us. So we chose PHAs.
Yeah. And when you look at barriers themselves, of course, you mentioned the flexible film side, and there is that huge challenge that we have in order to really kind of provide an alternate to the current multi-layered petroleum-based substrates, which are not going to go away for 100,000 years or more, who knows?
Right.
And then, even when they go away, they probably leave behind a lot
Right.
on the planet.
Right.
And but then the challenge is, of course, that the kind of barriers that are being provided for water vapor and oxygen are so stringent,
Mm-hmm.
and companies are so used to it. So do you look at it positively that eventually as humans we will be able to evolve a substrate which has got that kind of barrier property and is able to perform at similar kind of levels?
Yeah, so I think the part of it is the similar kind of levels. Obviously, the fossil-based barriers are very good at what they do, and that's why they've persisted for so long, no pun intended, in the market. But it really then is a matter of innovation for me, is that the brands, the companies are, again, trying to now peel apart what barrier performance is really needed, not just setting the specifications at what was available.
Mm-hmm.
So it's really a matter of more carefully looking at the life cycle of that product and then figuring out what the appropriate level of barrier performance that will be needed is, and try to meet that. So I think I think where the industry is in the process of redefining the requirements for barriers, and different products would have different needs. So whether we'll get to the holy grail of the same levels as the traditional materials, probably not, but I think you'll get more flavors and nuance in the products that give you what is needed for the particular application. So we're seeing that shift in the market, definitely, where people are taking a closer look at what is actually needed in products. Yeah, and then I think in the high barrier, oxygen and moisture barrier are both important. Again, depends on the application need. So we have the new biomaterial that we're working with, which is a partnership with IFF, is a very high oxygen barrier.
What does IFF stand for?
International Flavors and Fragrances.
Okay.
So they have this enzymatic polymerization process that makes this biomaterial, and it has very good oxygen, low oxygen transmission, so high barrier for oxygen. So we're working in partnership with PA Consulting in the UK to bring this technology to market. So you should be seeing more traction in the market soon. In the next year, I would say you would start to see more of our announcements with regards to this product in the market. So we're focusing both on the sort of the traditional OGR type barriers, as well as some of the more high barrier products in the market. But again, we're keeping a very close eye on not just performance, but also the regulations, because that's part of what this whole industry needs to learn, is where the regulations are headed. I think there's a lot of moves in that direction, but it needs to settle a little bit before companies take the real serious bets on some of these technologies. So I think that's where clarity will help
And do you think with scale coming in both these materials, especially the enzymatic side as well, do you think the cost factor would also become more acceptable to the customer? How do you see that transition happening?
Yeah, again, I think customers are, looking at this as a value added product because there's, many trends that are taking place in society as well. So, for example, like, the customization trend or differentiation is one. So packaging on your stores typically has a lot more customization to it. And convenience and to go is a big one. People want on the go packaging. So that's another driver. So whether you need as much shelf life for as long is a question mark, right? And it's more about convenience. New models could evolve where you need essentially, if you get some combination of refillable with a flexible pack, where you essentially need it to last long enough to where you can refill your package with it. Yeah. Maybe you don't need the, 12 shots. Yeah. Right. So I think these, as innovation and these new models of packaging evolve, I think some of these will get redefined in the market. But these are some big trends we see. And then I think carbon responsible. So basically customization, carbon responsible is another trend we see. Convenience is one we see. And then closed loop is another thing we're seeing where a lot of these packaging are reused. Exactly. So I think price is a factor, but it's again the value, and it's the value in use really more than price per se. And as we scale these, obviously the economics of scale, the economies of scale will play, and the prices will come down. And I think we're at that stage where, with this DEB platform that we have, for example, we're starting to introduce starting volumes for sort of market development, sort of small scale volumes. We're already in the process of building a plant to seed the market for the early adopters. And so, the plan is to scale these up to where they become certainly cost effective in the market. So I think, just thinking in terms of the price parity is the wrong way to think about this.
It's the value
creation, and these traditional materials have so many drawbacks to them that we really need to. And I think society is coming around to it. Now, of course, different developing world has its own needs. I think the developed countries have a different path, perhaps, they will take. So
it'll be a mix of kind of solutions as well as regulation, as well as, driven by the buyers, the consumers. Exactly. So it's a kind of a mixed bag ecosystem that might evolve as we go along.
Yeah.
The other thing which I've been always kind of interested in, and I think sometimes as people in the innovation space, we look at our effort as replacement instead of creation.
Right.
So what happens then is that a petroleum polymer-based substrate has been created as a multi-layered substrate to provide different properties. And when we look at a 3D structure in, say, nature, like it could be multiple systems, many times it's a monomaterial with a different gradient of if it's a cellulosic fiber, it can go down to the nano level, and, the structures are differently created with the similar kind of material.
Right.
Do you also see a movement on the monomaterial side to create still a high barrier structure, but it's not a multi cross-functional kind of material? Do you see that happening? And are you able to, in your R&D, are you able to break through that mindset that you're not replacing, you're creating?
Yeah, I think for some of these high barrier applications, I mean, you're trying to get those functional layers so thin that it can essentially function as a monomaterial, that it can be recycled, that those other functional layers are not interfering with the recyclability of the product. So that's a focus for us. We're trying to optimize the functionality with the coat weight, if you will, for these materials. Monomaterial is more commonly thought of in the recycling streams when you're thinking about the plastics, where they can go into the plastics recycling stream without bringing a lot of contaminants into the picture. But I think some of these complex enough problems, it's hard to find one material that brings both MBTR and OTR, for example, to the table, because the molecular structures are different. The hydrophobic nature is different. So it really is, having that wonder material that does it all is unlikely. But we're certainly, I think, the optimization to where you minimize the amount that you use, try to optimize the design So circularity by design, for example, trying to design for circularity, I think is a very important part in achieving this recyclability. So that's, I think, monomaterials in the sense of as a goal, I think is more traditionally on the plastic side, but we're trying to have paper that it can be recycled in the paper streams with ease with our materials. So that's our immediate focus.
And you mentioned in between about the PFAS challenge, and of course, we know that that is the big gorilla in the room, and everybody's trying to solve that. How soon do you think that there'll be a viable solution that actually works to the same level of grease barrier? Because without that, it is the challenge. In fact, many times you need a higher grease barrier than what is present even in the current OGR kind of chemicals, and that may come through spraying or something like that. But through internal chemistry. Yeah. Is there something that either Kemira or somebody else you feel is going to provide a material that's going to be soon enough to not have that discussion anymore?
One certainly hopes so. I think there's a lot of efforts, and I really believe that human beings have shown that innovation is capable of anything, right? So I see a solution on the horizon. Now, when it'll come, I don't know. I don't think of it in terms of matching the OGR of PFAS, but it's really matching the OGR of the application.
Okay.
So, I think once you clarify the expectation, then we can work towards finding solutions that meet those requirements. Now, it may take some re-envisioning product use, for example. So, but again, some of these materials have persisted as long as they have because they are sort of wonder materials. They just do the job spectacularly. But as I think society is becoming more environmentally and health conscious, which I think is a secular trend, I think everyone, whether or not you're on the skeptical side of that or I think everyone universally is a little more conscious of,
for sure,
their environmental impact. They're thinking about it way more than they ever did. No one takes it for granted anymore, is my view.
And probably, I think what you interestingly said is health. And I think they both go together. Hopefully, people will eat lesser packaged food, and
exactly.
hence also might lower the shelf life or something.
Exactly. But I think this is what COVID showed us. For example, the whole QSR model changed from being on-site dining to takeaway. So the whole packaging suddenly had to adapt to meeting the needs of somebody that's driving by and picking up their food. So things like leak through became much more important because you've got something sitting on your lap. And so, I think as behavioral pattern, as some of these social trends change, I think some of the product expectations. And so I think it's going to be a convergence of these different things. So I think solutions exist, whether they'll be product that has the same level of OGR that PFAS, TBD.
That's it. Okay, so you've mentioned a few times about the importance of collaboration and the amount of effort Kemira is making, and it's pretty widespread. Like it seems, of course, there's lots of collaborations on the technology side. There's collaborations with customers. There's collaborators with developers. So how does Kemira see that? Why is it so important? And why can't Kemira do it all itself? It's such a huge company with a lot of expertise. So how does that work in Kemira's favor?
Yeah, I think partnerships are key, especially across the ecosystem, because there's an interdependency of technology. So there's both developments on the technology side, as for example, on the molded fiber side. Now, a lot of thermoforming companies are developing machines that are specifically geared towards molded fiber that made traditionally plastic thermoformers, right? So you've got that wave of products. I think there's the potential for new coating systems to emerge that make drying easier for aqueous coatings, for example. But all that only happens as a result of talking to each other and attending conferences like this one and taking a pulse of the room in some sense, getting a sense of where the industry is headed. Because there's a enthusiasm and urgency to the situation that I think people want solution, but they also want clarity on the regulation side. So unless you get this systems approach to the whole thing, from the regulations to the consumer expectations, to the technology push, to the brand commitments, to people like the Ellen MacArthur Foundation pulling it all together, I think it's becoming clearer and clearer that partnerships are the key to doing that. And I think if you find a few key strategic partners, then you can accelerate progress, because then you've got more minds working on the problem. So I think it's, we see that as a critical part of success.
Very interesting, because obviously traditionally companies would keep it all internally, not share what they have, because of course it's two-way sharing then. So does Kemira also look at not just collaborating with more established players like Danimer and IFF, but do you also look at investing in, say, young startups? And how does that work? If there is a young startup listening to this, would they get excited because, a established company like Kemira may want to partner them too?
Yeah, I think we are constantly scouting the market. We have a pretty good read on the startup scene. We track who's doing what new interesting products are coming in the market. So very active part of what we track in the market. And with this new operating model, with the new ventures and services business, I think we'll evolve new ways of harnessing that startup energy, because sometimes it's a solution looking for backing, and industrial backing, right? And scale is always a problem for startups, and the capital is an axis critical, as I see it, I think, and as Kemira sees it as well. So we're always interested to hear about startups and what they're up to.
Nice. And how do you, in clubbing with that, how do you look at talent? Is there a lot of young energy that Kemira is trying to get? How do you personally look at it? How does one even attract talent to this domain, which is really important?
Yeah.
And how do you go about it and ensure that there's a lot of young energy that doesn't still know that it can't be done coming into the industry?
I think you look at some of these startups in the space, you see the age of the founders and things like that. There's young energy in there. And I think it's just an exciting to feel to be in sustainability. I think a lot of very sharp minds. I just had a summer intern who I was completely impressed. We have two others. We had 3 summer interns this year in our team, and just the quality of clarity they have and the ability to think strategically has been really impressive to me. So I think tapping into youthful energy is key. I think you bring the experience, they bring the energy and the enthusiasm, and there's a happy marriage there.
And they haven't been jaded so far.
They haven't been jaded. Yeah. So, and then AI, I think, has the potential to really, make life a lot easier by helping us focus on the creative side and the ideation, and AI can help us provide some of the structure and the organization, or fast track some of the research.
Yeah, shortening of the cycle.
So I think our generation is living through an incredibly exciting time in humankind, right? So we're living through transformational stuff in almost every sphere, right? The pace of change is incredible.
So is there anything else that you think I have missed and you want to add from Kemira's standpoint or from Sanjay's standpoint?
Like I said, we're solutions providers. You're going to see more of us in this space, leading solutions in this space. So, I'd say stay tuned, because we've got good things coming.
It's so good to hear. Okay, so 2 last questions, and taking it towards closure. How are you thinking, and you've mentioned this a couple of times in terms of separating the business, how are you thinking of scale in terms of Kemira's world? Because Kemira itself has already scaled, but this new business, say in terms of 5 years, you mentioned 500 million, which is a huge target. So what is it now? And, and then, how are you seeing achieving that in the next 5 to 6 years?
Yeah, I can't really give you current numbers, but we're well on, we have a vision and we have a good path to achieving that. For example, right now itself, like % of our raw materials are either recycled or renewable as a source material. 71% of our energy use is emission free. So we're very committed to this sustainability vision. So this is a big push for us. So I think when you've got that kind of focus as a company, the numbers will show it. So in terms of scale, I think the other thing is the new ventures and services unit allows us to incubate and fast track the early stage commercialization of some of these technologies and get them quickly to a point where they can transition into one of the business units to get that sales force and the resources that come with the business unit to actually spread the product out in the market and get it out there. So yeah, we see it as a natural progression that we look out on the horizon, find the new technologies, bring them in, get the early work done, get it going, prove it out, get it prototype stage, get it to early commercialization, and hand it off. And so we're constantly trying to shrink that cycle time for that.
Yeah. Oh, that's amazing. And that all good things must come to a closure. So what is good garbage for you?
You know, I was thinking about this question. So I think for me, it's four things. So it's less garbage, first of all, right? It's delayed garbage. So you don't...
More cycles.
Yeah, or you just, you take your boxes and use it as Tupperware, or wash the bag. And so you don't toss it out right away. So it's not as quickly disposed of. So it's less, it's delayed, it's reimagined or repurposed. So if it's got to be garbage, can you think of another life for it as another product, recycled? And I think last but not least, it's non-persistent garbage. You definitely don't want it to stick around forever. So to me, so those are the four things: less, delayed, repurposed, and non-persistent.
It's definitely a new definition for good garbage. So thank you for that, Sanjay. As always, it's such a joy to talk to you and learn from you because of your wide exposure and understanding. I think each conversation I have with you, I'm left more wealthy in terms of knowledge. And it's such a joy. Thank you for joining me. I know that this has been a delayed conversation, but we could do it in person. So I think for me, it's really worth it. So thank you so much for your time and your interesting work that you guys are doing. Kudos to you. And I look forward to all the amazing things that are going to come out of this effort.
Thank you. Thank you very much for inviting me. It's a pleasure.
Thank you for listening to the Good Garbage podcast. Follow us on social media to never miss an episode. Links are in the description below. I'm your host, Ved Krishna. See you next time.